Hello, my viewers. From my heart of heart, I say a very big thank you for having watched my previous video. I sincerely appreciate you for your time. Thank you for watching the video and keep on watching. If you have not subscribed to my YouTube channel, subscribe Something Valentine in YouTube, as I'll be dropping a daily step-to-steps on how you can start your solar installation from scratch to the professional level. I remain myself, Samson Valentine, the celebrity engineer, popularly known as Rexam, the solar doctor. I am here today to give you a treat of one of the components which I mentioned at our start in the previous video. I mentioned about the solar panel which I've talked about. Today we'll be talking about the deep cycle battery for the solar system. Permit me to introduce you to what a deep cycle is. Deep cycle battery is a battery, or you can equally see it as a lead acid battery, that is specifically designed to discharge and recharge at a regular interval. So on this note, I want you to know that deep cycle battery is quite different from ordinary batteries you gather. It is quite different from the batteries you use in your car. It is quite different from the battery you use in your motorcycle or your tricycle. It is quite different from other batteries you see all around. So there is a specific battery that is meant to power your system, and that battery is called solar battery, otherwise known as deep cycle. In deep cycle, we have series and different types of them. We have the AGM, we have the valve regulated, we have the lead, we have the lithium, we have the tubular, we have SMF, and so on. Dry cell and wet. The one of wet is classified under the category of tubular, which we all use every time. I want you to know the difference between the dry cell and the tubular battery. Tubular battery actually demands little maintenance because it will take your time for you to know the time that the distilled water is reducing. How do I mean? It will take you some period of time to be monitoring the gauge to know when the distilled water reduces so that you can revive it. But in a dry cell of this type, you don't really need anything to monitor. All you need to know is to know the cycle at the beginning, know the internal resistance, and all the necessities at the beginning. And once it is installed, you can only monitor it during the time of its failure. Remember, deep cycle batteries have a very high lifespan because it has the ability to withstand high loads compared to your regular batteries. Today I will teach you two things, and the two things are two important things you need to know as a beginner, which will help you to identify the things you want to do and achieve them properly without mistake. Because we actually know that the fault we encounter in solar system is usually as a result of the mistake we make during the first installation, or when you get the actual calculations and get the normal load that the inverter is meant to carry, you are not going to have problem with it. Permit me to introduce you to two things, and those two things today is I'll be teaching you how you can calculate your load, and equally teach you how you can know the hours of your battery. Understand? How do I mean? I mean I'll be dropping the ways you can calculate the loads that the system will carry, and teach you how you can use that load and know the number of hours that your battery will serve you without going down, because it is actually what makes the system sustainable. How long it lasts is determined by these two things. So first of all, like I told you, that lead deep cycle batteries are actually meant to discharge and recharge, and that's at it discharge at lower rate and charges at fast rate. So when it discharges, once it is fully charged, it is meant to be going out gradually. When it is connected to an inverter and you load it, the battery is meant to be discharging on a small interval, very slow, very slow. But when you are charging it, it is meant to charge faster to regain the power and use small time discharge period, so that, because if it charges faster and discharges faster, it means the battery is not serving you well. So first of all, let's take a look at how we can calculate the loads that we are going to use and know the size of inverter that is needed for the load to be sustained. First, you should know the load in your house. Some load are rated in watts, some are rated in kilowatts. When we are talking about load, I'm talking about the appliances in your house. And when I'm talking the rating, I'm talking about the power rating, which is expressed in watts. That is the wattage. So first, you should know that your bulb, electric bulb we are using, have 5 watts, 10 watts. You should be able to know that the ceiling fan or the standing fan is rated at 70 to 80 watts. Your TV is 70 watts. Then we have our ACs, which is rated in horsepower too. So horsepower means 1 horsepower is equivalent to 746 watts. Then we have our fridge. Because they are made of compressor, it can be 0.5 horsepower, which is roughly 426 and above. So all these things are the things you need to know when you are considering the size of inverter that will serve effectively in your apartment, or that will serve effectively in your site. So as an installer or as an owner, you should know when you are overloading your inverter and try to minimize the load so that it will serve you effectively. First, let me tell you how you can calculate those things and know the number of batteries and the time that the battery can run down when you are working with the load. So first, assuming you have a load of 800 watts, it is meant that you express it in VA, that is voltage ampere. How do I mean? When you are about to get your VA, you are express it in such a way that the power is over the power factor. And we know that power factor is filled from the calculations. As an installer or as an engineer, we have the power factor either 0, if you are using 0.75, good. If you are using 0.8, they are all good. So for me, in my own installation, I basically use 0.8. So if you are using 0.8 and you have the load of 800 watts, for me to get my VA, I have to express it by using 800 watts, by using 0.8 to divide 800 watts. And when I do that, I will have 1000 VA. And when I get up to 1000 VA, it simply means that my load is actually at 800 watts, but in VA, it is 1000 VA. Then converting the 1000 VA to kVA, you can express it by dividing it by 1000. So 1000 divided by 1000 is actually 1, which is 1 kVA. Hope you understand what I said. Now that you have gotten your VA to be 1000 VA, if you want to express it in kilo, which is 1000, so if you divide 1000 by 1000, it will give you 1 kVA. Then actually, what you have gotten is 1 kVA load. Then how then do you express it so that when you get that, you know the size of inverter that will power it? So if you have a load of 1 kVA, it is obvious that you cannot use exact 1 kVA to run it completely. Why? Because you need to have what we call tolerance. As the machine is working, you need to have a tolerance, a space whereby it can accommodate any unseen factor that may occur. For instance, you have a load of 1 kV as calculated, so I am not meant to power it with the exact 1 kVA. So for me, I go above 1 kVA. So if I must start up the load, it must be from 1.2 kVA to 1500 watts, understand? So since I have gotten my VA to be 1000 VA, so any inverter that I will use to start up a load of 1 kVA must be above 1 kVA. And when you do that, the system will serve you very well without problem. But when you start it with 1 kVA and your load is exactly 1 kVA, you see that any slightest addition of load will make the inverter to trip. So now that we have known the VA and the inverter, so from there you can calculate, even if you are using 10,000 watts as load. So you should run the equivalent of 10,000 watts and make sure you make a recommendation of the inverter that is above 10,000 watts. If your load is up to 3,500 watts, that means your inverter recommendation should be above 3,500 watts. It should be from 4 kVA in order to accommodate the load. So now that we've gotten this, I will equally tell you how you can make your battery to last. First of all, by knowing how to calculate the running hour of the battery. The running hour of the battery, like I said, is determined by two factors. First, you need to know the voltage of the battery. Secondly, you must know the amperage of your battery. Then, since you have gotten your load. So in that case, the period at which the battery will discharge, or the maximum period that the battery will last when it is fully charged, is determined by three factors. One, the battery voltage. Two, the amperage of the battery, and the load. And when those things are put together, we run the calculation of the downtime. The time includes the voltage of the battery, the amperage of the battery over the load. I bring in again our load as calculated. We were able to establish the fact that we are going to power 1000 VA load from our calculation. So currently, let's check the time and the number of hours that the battery can sustain it. Perhaps on my table here, this battery is 12 volts by 7.2. Then I have this one here, which is the same 12 volts by 40 amps. 12 volts by 40 amps. So in this case, if I am using to run the load, it will actually be too small. And the number of hours I will use this to carry the load of 1000 will not be much. So let me say, for instance, we are going to run a load of 1000 VA with the battery of 12 volts by 200 amps. So I'm going to calculate it. Just follow my steps as I do that. First, the time is equals to battery voltage multiplied by battery amperage R all over the load. Imputing the figure, my battery voltage is 12 volts times my 200 amps AH all over my 1000 VA. Then calculating it with this, I'll be able to get like 2400 divided by 1000. So when I do that, I have been able to establish the fact that the time it will take that battery to discharge completely with the load of 1000 VA is actually 2 hours 40 minutes. It means if I'm carrying one battery, 200 amps battery with 12 volts, it has the maximum discharging limit of 2 hours 40 minutes. Below that side, it means the battery is insufficient of doing the job. And you have to trace down what makes it ineffective. Likewise, if you are to get above 1 batteries, after running your calculations, maybe you run parallel connections, so you have to sum them together after your parallel connections and make sure you establish the total voltage that you got and equally the load you're using it to power. The same way, if you run series connection, that series connection will equally give you a sum of the voltage and the sum of the amperage of the batteries you use. Then you divide them by the load and know the number of hours that it will serve you. And when you do that, you will be rest assured that whatever thing you tell your client that this is the number of hours that this battery will serve, and that is actually what it is going to serve. Please, if you have not subscribed to my YouTube, go down now, click on the subscription button and subscribe. Then turn on the notification bell so that you'll be getting notification the moment I upload the next video. Then permit me to also introduce you to the ways you can know the battery when it is good or when it is bad. How do I analyze my battery? Last time when I was talking about multimeter, I told you that we have digital multimeter that we use in determining a lot of things about our panel and the batteries. So today I'll be talking about the analyzer. This analyzer is very, very essential in installation. Very, very essential. This is actually what will make you a professional, and this is what will make you to be sure of what you are doing without doing guesswork. You'll be able to establish the fact that my battery is okay before I run the installations. You use it to check what's happened after the installation. You use it to check pre-testing before installation and post-testing after your installation. So it is actually very, very necessary that you know how to use this and know the state of your battery before you run the installation. Even before you buy any battery from the market, it is advisable that you consult a professional that knows how to use this to get you a good battery. So I'll be showing you how to use this. If you have a solar system in your house, you actually need this standby too to ensure that your system is working effectively. So, like I told you, every electronics measuring instrument, your electrical, always comes with a cable or terminals. This is the probe. This is the cable. Remember, we have analog and digital. I love working with digital because it gives me accurate measurements. The digital gives me accurate measurements. So that is why I love working with the digital. Everything I'm doing is digital. So that is why I bring it to this digital multimeter, digital analyzer. I will be showing you how to use this. First, this is my positive side. This is the negative probe, and this is my positive terminal, and this is my negative terminal. So I will connect my positive to the positive side. But before then, you should know that this thing doesn't have internal battery, therefore it cannot trigger without the battery you are measuring or the battery you are about to test or analyze. So for it to come on, it must go to the battery you are about to analyze before it comes on. So just be watching me. If I put it now, it will turn on automatically. Have you seen it? First of all, as it pops on, it shows you that the voltage of the battery immediately. The voltage of this battery, it is rated 12 volts, but because it has been charged, it is 13.01. And remember that when a battery is fully charged, it is actually at 13.0 to 14.4 volts when it is fully charged. Every 12 volts battery that is fully charged is at the range of 13.0 to 14.4 volts. So now this is actually at 13.0. It means this battery is charged. So for me to analyze, I have to take it down by selecting yes, battery test. Am I ready to test? That's what it asks me. So I'm going to test by saying yes. Saying yes means pressing the enter button. I've pressed the enter button. Can you see what it's showing me? I should select the battery type. That is why I took my time when I was starting to tell you the types of battery we have. This thing you see is gel regulated, valve regulated, and gel. So because of this is gel. So I have to select enter. Then it will bring me to rating standard. So the rating standard, as an engineer, there is a society we called Society of Automotive Engineers. So those are the people that took time to calibrate the measurement you are about to take now. So it's a Society of Automotive Engineers because this is automotive. So I will select yes. From automobile, you get it. It's the association that was able to calibrate this through the instrument engineers. So we're able to get it. So now it will ask me to choose the rating capacity. The rating capacity is actually, if this battery is 200 amps, that means I will leave it at 200. If it is at 500, I should leave it at 500. But because the battery amperage is not up to 500 that is seen here, so I'm going to bring it down to the amperage of this battery. This battery is rated 40 amp H. 40 amp hour is what it is rated. So I will do that by reducing it down. Reducing it down. As I'm bringing it down, this is 40. So once it is 40 like this, I reduce it to 40, then I will press enter. Now, it has analyzed and it has showed me that this battery has a cycle of 286 cycle. 86 cycle. So the cycle actually determines how long it can still serve or how long it will serve. So this battery is meant to be, if it is newly battery, once you get it from the beginning, if it is 200 amps, it should be from 300 to 5,000. From 300 to 5,000. But because this one is a small battery, just 40 amps, so you see it's still at a good rate, 286 out of 300. So now the analyzer will give me the next step. If it is bad, it will write it bad, replace. That is why it is digital. Now because it is good, the analyzer said good, pass. And it now showed me the remaining cycle for the battery. So what do I check again? I have to check the state of health, the state of charge, and equally the internal resistance. From my state of health, the battery is okay, 100% okay. Then I'm going to check my state of charge now. The state of charge is 100%. It means the battery is fully charged and is okay for use. Then I will now check the internal resistance. The internal resistance is here, 12.14 milliohms. When you are checking for the one of 200 amps, 220 amps and above, if you are able to get the cycle at between 500 to 1000, the internal resistance should be from 0.4 to 6 milliohms to show you that the battery is at a good state. It doesn't have fault. Why? Because if the internal resistance increases, the cycle decreases, and the increase in the internal resistance also causes the increase in discharging rate. So the depth of the discharge increases as the internal resistance increases. And in the same way, the charging rate decreases as the internal resistance increases. If the internal resistance is too high, no matter how many hours keep the battery to be recharged, it will never handle any load after charging. Why? Because the internal resistance will not allow the current to be stored in the battery anymore. Why? Because the internal resistance has gone too high. Remember, this is measured in milli, not even in ohms. It's in milliohms. So the moment it increases and keep on increasing, the cycle will keep on going down. That is how it works. So I'll be showing you the next one so that you see the difference between this and this. So this is actually 12 volts by 7 points. So now this is not charged. The voltage is not up to 12 volts because it is not charged. So therefore, it is 8.4 volts. And remember that the amperage is too small. That means the capacity or the SAE that we are going to run with will not be up to 40. We are reducing it. Testing. Now, the cycle for this battery is 3097 cycle is what is remaining. Even though it is not charged, but the cycle will be shown. Why? Because the battery is still okay, just that it needs to be recharged. So now we said good, but recharge. Remember the first one said good, pass. That means it doesn't need charge if you can use it. But this one said good, recharge, means the battery is good, but you cannot use it because it is not charged. So let's go and check if it is, if what this analyzer is saying is true from the next stream. The state of health of the battery is okay, it's 100%. Then the state of charge, SOC, is 0%. It simply means that the battery is not charged at all. It needs to be recharged in order for the state of charge to increase. Remember, the first one we had 100%, but this is 0%. So this battery needs to be recharged, fully recharged. Then the internal resistance is okay because the cycle is okay. The internal resistance is okay. The internal resistance is 0.0 0.57 milliohms. So what this battery needs now is charging. So we'll be taking it for charging so that it can serve us very well. Any load you apply with it now will not serve. Remember, this battery is mainly used in our various UPSs. Uninterrupted power supply, the common UPS we use to power our computers. This is what is inside of it. So for me to use this with the UPS, I have to get it charged now. That's what the analyzer is telling me. So it is very, very important that you know how to use your analyzer and determine the cycle, and equally know the number of hours that your battery can serve you and serve your clients as an installer, and equally serve you as a user. I am very glad that you are following me, and I urge you to keep on watching my videos because I will be bringing next one to you. Thank you very much as you keep watching.